When it comes to planets in our solar system's habitable zone, one world is too close to the sun, another is too far, and Earth is just right. But maybe things would be different if Venus and Mars simply swapped orbits. What makes these planets impossible to live on right now? What changes would they undergo when they traded places? And why would you need Jupiter to give these planets a chance at supporting life? This is What If, and here's what would happen if Venus and Mars swapped orbits. Our solar system's habitable zone, otherwise known as the Goldilocks zone, is the distance from a star where liquid water could exist on the surface of a planet. As long as conditions aren't too hot or too cold, life could be possible, just like on Earth. But simply occupying prime real estate in the habitable zone isn't a guarantee that a rocky planet is actually habitable. Both Venus and Mars orbit within this region too, and yet no life. Despite being of a similar size and with roughly the same surface gravity as Earth, Venus is too hot to hold liquid water. And dense. Its atmosphere is 90 times denser than our own, and the surface temperature is a scorching 462 degrees Celsius. On the other end of the Goldilocks zone, Mars is also quite Earth-like, except way colder, drier, and dustier. Its average surface temperature is minus 46 degrees Celsius, and it has an atmosphere about 1% as thick as Earth's. So, if we swapped things around, would Venus and Mars transform themselves into perfectly livable planets? Bringing the red planet into Venus's orbit would put it at a distance of approximately 108 million kilometers from the Sun. This would bring it halfway closer to the Sun than it was before. Being so much closer, Mars would get a significant boost in the amount of sunlight it receives, and that alone can make the surface temperature climb to a balmy 32 degrees Celsius, just like the Earth's tropics. But without a thick atmosphere or oceans, all this new heat wouldn't stay on the planet. Just like in Earth's deserts, Mars would see extreme temperature differences between day and night. The thin Martian atmosphere would make it difficult for water to stay liquid. With such a low surface pressure, water would boil at a lower temperature. Evaporation would happen much quicker. Looks like if you want to see life flourish on Mars, you'd have to take a slightly more hands-on approach. But first, let's check out how Venus is doing in its new neck of the woods. You'd now find Venus located 228 million kilometers away from the Sun. That's twice as far as it used to be. And naturally, you'd think, surely this scorching planet would be starting to cool down. Well, as it turns out, the planet's high surface temperatures have a lot more to do with its thick atmosphere than its overall closeness to the Sun. Venus has a very high albedo, which means that it reflects about 75% of the incoming sunlight. So it could be that the planet's temperature remains more or less just as hot as before. Even as the upper parts of the atmosphere slowly cool enough for the albedo effect to decrease, that would mean that Venus could now absorb a larger amount of incoming sunlight, so that temperature wouldn't start to drop all that much. Another setback on the road to becoming a life-supporting planet would be that Venus's atmosphere is mostly comprised of carbon dioxide, with small amounts of nitrogen and clouds of sulfuric acid. What you still wouldn't find nearly enough of is water. The concentration of water in Venus's atmosphere is 100 times too low for even the most resilient organisms back on Earth to survive. But since you went through all the effort of bringing both planets from one end of the habitable zone to the other, why not take things a little further? You could try terraforming the planets to make them a little more livable. One way you could increase the surface pressure of Mars would be to try releasing all the carbon dioxide found in its soil and minerals. The only problem here is that the red planet would need to reach temperatures above 300 degrees Celsius. And despite this new location so close to the Sun, Mars wouldn't ever get this hot. Besides, if you could release all of that precious greenhouse gas, it would only amount to an atmospheric pressure of about 10 to 14% of Earth's. There simply isn't enough carbon dioxide on the red planet. Even if you had been successful with that effort, you'd still be unable to breathe on Mars. One option for dealing with this would involve bringing special microorganisms to the planet that could convert the hostile Martian atmosphere into breathable air. This would be similar to what Earth was like 2.5 billion years ago. Back then, cyanobacteria converted our methane and ammonia-rich atmosphere into the oxygen-rich one you enjoy today. But ultimately, this would be a big waste of time and resources. You'd find that with Mars's weak magnetic field, it wouldn't be able to hold on to any atmosphere you could create. That would be thanks to the power of solar winds that would constantly strip away whatever atmosphere you'd managed to generate. And sitting in Venus's old orbit, solar winds would be almost 5 times as dense as Mars is used to. Way out on Venus, the question of creating conditions for life could come down to whether you could manage to form an ocean on the planet. And that would entail bombarding the atmosphere with hydrogen. As hydrogen is introduced to the atmosphere, it would react with the carbon dioxide, leading to the formation of water. Introduce enough hydrogen and you could eventually see Venus with 80% of its surface covered in water. For this to work, you'd need a lot of hydrogen. So much that you'd probably need to find a way to harvest it from a gas giant like Jupiter or Saturn, or maybe one of their moons. Yeah, I'm not sure all this planet moving and hydrogen bombarding was really worth it. You'd still be left with only one Goldilocks planet capable of supporting life. But what if all the planets were in the habitable zone? Well, that's a story for another What If.